It's like so much fun. I forgot. Well, so they like, yeah, so it's like she meets with the people. She was like such a cute person. And then it's like, okay. Such a big especially this
Okay, so today's class is on impact, and we'll study two kinds of impacts. One is central impact, which I just drew, and oblique impact. Central impact is when you have a head-on collision. Okay, and to analyze motion, typically we know the speeds of those two spheres before impact. We'll call them VA1 and VB1. We're interested in finding what happens after impact. So VA2 and VB2 are unknowns. And since there are two unknowns, we need two equations to solve the problem. So one equation comes from conservation of linear momentum, what we covered last time. The other equation comes from an empirical relation between how they move. It's called the coefficient of restitution. This is very much like friction coefficient. You find it experimentally. It's defined as velocity of separation divided by velocity of approach, and it's important that you put this in the right way.
What is that last word? Coefficient of what?
Restitution. Okay, it's very important that you write it as when everything above on the numerator is 2, and that is after impact, and if everything below is 1 before impact, and it's V minus A. If you have VB minus VA on top, then you need to put VA minus VB. You can switch the signs. Well, if you switch the terms in the numerator, just switch it on the denominator. It doesn't matter how you have it. You could put VA2 minus VB2, but then you'll have to have VB1 minus VA1. Okay. Okay. So what about E? E is as I said, an empirical quantity. Let me talk a bit about E.
Is that VB2 minus VA? Or VB?
P and A. Yeah, this is. It's only A and B in this formula. So let's talk about the coefficient of restitution. Okay, so friction, how do you find the coefficient of friction? The classical experiment to find friction is you take a block, you put it on a ramp, and then you keep increasing the ramp slope till the block slides down, and that angle gives you the coefficient of friction, right? Similarly, to find the coefficient of restitution, what you do is you drop a ball on the floor, on the ground, and if it, depending on how high it bounces off, and how high you dropped it from, you can find the coefficient of restitution. So if E equals 0, which means that essentially if you look at the terms, it's velocity of separation divided by velocity of approach. The velocity of separation is 0. That means that the velocity after impact is 0. So imagine dropping a ball, it doesn't jump up. It means, in which case it means it's a purely plastic impact. V after collision is 0. Oh, it's called sticking impact. E equals 1 is the other extreme case, where if you drop a ball and it spring backs to the same height, which means that it approached with the velocity v, it shot back with the same velocity. It's called elastic impact. Okay, and we know that most of the time it's not E equals 0, equals 1. It's typically between 0 and 1. This is called an inelastic impact. Okay, so again, the way you find E is depending on, actually there's a problem where we'll talk about how height depends on the coefficient of restitution. You drop a ball, it sticks, plastic impact. You drop a ball, it springs back to its original height, it's elastic impact, and it bounces back to a height which is less than the original height. So falls from here, jumps and comes back here, that means it's a inelastic impact. Do you get a situation where you drop a ball with 0 speed, it'll spring back above the height it's dropped? Have you seen anything like that? It's actually not possible. It's hyperelasticity is it will violate the conservation of energy. If you drop a ball from a height h and it springs back to a height which is greater than h, that means that energy was. Okay, the only difference is from the previous figure is now the balls are not approaching to each other with a speed which is along their line of impact. So if you have two balls coming or spheres coming with velocities which are at an angle like this, then you have oblique impact. Let's call this x, call this y. So you can see that the velocities are not along the line of impact, which is the line joining the centers. Okay, example of an oblique impact is, well, central impact is people going on the wrong side of the interstate, head-on collision. An oblique impact is more like when you see people breaking a stop sign, you'll have an oblique impact. It's less severe, but it still can be catastrophic. So how do we analyze this situation? Well, in this case, again, we assume we know the velocities before impact. So we know the velocity, we know the angle which the velocity makes with the x-axis, and we want to find the velocities after impact. So velocities after impact, in the previous case, velocity after impact was just velocities along the axis, so one dimensional. In this case, it's two dimensional. So we're going to find the velocity in the x and y direction for A, x and y direction for B. So we have four unknowns. So we need to generate four equations. So these are the four equations. They come from conservation of momentum along line of impact. Okay, so I'm going to denote VAX and VBX to be the velocities along the x-axis as I've shown here. That's our line of impact. So mass times velocity of A in the x direction before impact plus mass B, velocity of B along x direction before impact equals MA VAX after impact plus MB VBX after impact. So then we have conservation of momentum at right angles to line of impact. Okay, at 90 degrees. Okay, let me move this to a different page. Now, this is something which people get confused. We assume that the reason why we do conservation of momentum of both particles is because there's a impulsive force along the line of impact. However, we assume that there's no impact or no impulsive force at right angles. So it's called a frictional impulse. We assume that's zero. And the consequence of that is that mass times velocity of A in the y direction before impact equals mass of A, velocity of A in the y direction after impact. Mass of B, velocity of B in the y direction before impact is mass of B, velocity of B in the y direction. So this is a consequence of assuming there's no frictional impulse. And the third one comes from coefficient of restitution, which states that E equals VBX 2 minus VAX 2 divided by VAX1 minus VBX1. So those are the four equations which will help us to solve for the four unknowns which are velocity of B and A in the x and y direction after impact. Okay. Two smooth billiard balls A and B, each having a mass of 200 grams. If A strikes B with a velocity VA1 equals 1.5 meters per second. Okay, note you're given the velocity at an angle to the line of impact. Determine the final velocities just after collision. Ball B is originally at rest, and the coefficient of restitution is 0.85. Neglect the size of the balls. So this is a problem in oblique impact. We are asked to find velocity of A after impact, so VAX 2, VAY2, also VBX2 and VBY2. Okay, four unknowns. So we got to generate four equations. Let's get started. So before we do that, let's just resolve velocity of A in the x direction before impact. So that's going to be 1.5 cosine 40 degrees. Now here's something you want to do. This will avoid you getting the wrong answers. Always stick to a sign convention. When you have velocities going in the positive x direction, x or y, take that to be positive. In this case, the velocity in the x direction is along the negative x-axis. So I'm going to put a negative because the direction is to the left. Right? So this comes out to be minus 1.14 meters per second. And velocity of A in the y direction, go to resolve the velocity in the y direction, put a negative sign because it's going in the negative y direction. Okay, and obviously the velocity of B in the x direction before impact equals the velocity of B in the y direction before impact. It's simply equal to 0 because the ball is at rest. So now we are all set. Let's start with the conservation of linear momentum. Mass of A, velocity of A in the x direction plus mass of B, velocity of B in the x direction before impact equals mass of A, velocity of A in the x direction after impact plus mass of B, velocity of B in the x direction after impact. Okay, all the balls have the same mass, so you can just cancel masses. We're left with VAX, which is minus 1.14. VBX is 0. So this equals VAX2 plus VPX2. So that's, I'll call that equation 1. Okay, next let's do conservation of linear momentum in the y direction, and for that I need to do it for the balls individually. So mass of A times velocity of A in the y direction before impact equals mass of A times velocity of A in the y direction after impact. So masses cancel off. We know the velocity of A in the y direction is minus 0.96 equals VA by 2. That's 2. In fact, that equation we've already solved for velocity of A in the y direction. Okay, next let's use the conservation of linear momentum in the y direction for B. So mass of B, velocity of A in the velocity of B in the y direction before impact equals mass of B, velocity of B in the y direction after impact. So those two cancel. Velocity of B in the y direction before impact is 0, which means that the velocity of B in the y direction after impact is also going to be 0. Okay, finally, the coefficient of restitution equation E equals VAX2 minus VBX2 divided by VBX1 minus VAX1. So velocity of A in the x direction is minus 1.14. Velocity of B in the x direction, that's not right. I don't know the velocity, right? Those are unknowns. Okay. VBX1, that's the one I know, it's right here. It's minus 1.14 minus velocity of, my bad, velocity of BX here is 0 minus velocity of AX, that's the one which I should put here, minus 1.14. Okay, and that equals E, which is 0.85. So I can write VAX1 minus VBX2 equals 0.85 times 1.149. That comes out to be, should be 2.9767. Okay, that's equation 4. And finally, because I have 4 equations, 1 through 4, I have 4 unknowns, velocities of A and B after impact, I can solve for those 4 unknowns. So this is just it's a math problem. 2 and 3 actually gives me the velocity of A and Y. I just need to solve for velocities of A and B in the x direction. Essentially, it boils down to solving 1 and 2. So what you get is velocity of A in the x direction. I'm going to write this as a vector. VA after impact is minus 0.086 I minus 0.964 J, and velocity of B in the y direction, velocity of B after impact, it's 2, equals minus 1.63 I meters per second. This comes from solving 1, 2, 3, 4 for unknowns VA x2, VB x2, VA y2, VB y2. Okay, so what I want you to note is that velocity of B, so A and B are, A hits B and B has a velocity in the negative direction, so negative x direction. So, I mean, if you've played billiards, I think you can relate to this. If A hits B and B is at rest, then B is going to go in that direction, negative y direction. That sort of agrees with our experience playing billiards. So it's not like we've made this up, it actually comes from the math. Right? And this is actually only true, well, it's true because the masses of the balls are the same. If they were not, then it would be a bit more complicated. So if you suddenly replace the balls with two different weight balls, then it's a totally different game. It's going to be much more challenging, especially if you do not know the masses of the balls. Okay, so here is a question for you. And this is really a very basic question. It's asking you to find the coefficient of restitution between ball A and B. So E is what? E is always positive. Don't get a negative answer. So you're given the velocities of A and B before impact on top. You're given the velocities of B and A after impact. And my suggestion to you is stick with a good sign convention. This problem, people get it wrong when they when they just randomly put velocities, whichever way they want. Just stick to a sign convention. If you like, you can take the right side to be positive. So this is a short question. I'll just wait for, see what's the time there. It's 10:30. I'll stop at 10:32. I'm going to start. Put in the numbers. As I said, stick with a consistent sign convention. So this is going to be minus 2i, assuming that positive is to the right side. This is 8. Well, let's not put I just need to put the magnitude. Minus 2. This is going to be plus 8. This is going to be plus 9. And this is going to be plus 1. Right? If you don't stick to a good convention, you'll actually get the wrong answer. So E equals VA2. So everything over here in the numerator is after collision. So velocity of A is 1 minus velocity of B is 9. Velocity of B before collision, so this one is minus 2. And velocity of A before collision is 8. So 9 minus 1 is minus 8. That's 10. So answer is 0.8. So you should not get 1.33. If you get 1.33, you should not get a negative answer. So all these answers, that's 5 kg ball is fired from tube A with a velocity of 6 meters per second. Can at an angle of 30 degrees as shown. If the coefficient of restitution between the ball and the surface is 0.8, so this is 0.8. Determine the height h after it bounces off the surface. So we got to find this height. Okay, so first thing to think about is if you want to find h, you can find the height h if you know the velocity with which the ball leaves the ground. Okay? Now, how can you find the velocity with which the ball leaves the ground? If you know the velocity, it's approaching the ground, and you know the coefficient of restitution, then you can find the velocity after it leaves the ground, rebounds the ground. Okay? So we need to find the velocity at B before it collides, and that will help us solve for the height. So my first goal is to solve for velocity of B before collision using the projectile motion equations which we have studied in the past. So we divide this problem into two phases. One is projectile, technically three phases. Projectile motion from A to B. Then there is impact at B, and 3 is projectile from B to C. Okay, so let's do it 3 parts. So only solve for things we care about. So from 1, projectile from A to B. Okay, we're interested in finding the velocity here. Okay, so how can we find the velocity? Well, the velocity at B equals velocity, the initial velocity, Vy0 square plus 2g times the height. Right, this is a formula we've seen in the past, the formula relating velocity and the height h. So this is the unknown. Let's try to set up that equation. Velocity of y is in the, write it slightly differently. Velocity of y, we call it Vyb square. Okay, equals this. So Vyb square is unknown, equals velocity of y in the initial velocity is going to be 6 sine of 30 degrees, and my convention is positive is upwards, so it's positive square, 2 times gravity, which is 9.81, it is downward, so it's negative, and then height is also downwards, it's also negative. Okay, so that is a single equation in a single unknown, V by B. V by B is going to be, if you solve this, you get 6.94 meters per second. Okay, next is impact at B. Okay, we know the velocity of, well, let's write the formula for impact. E equals velocity of B, in this case it's going to be V by B, after impact, minus velocity of the ground. Right? There are two objects involved in the collision. There's the ground and there is the body. So I'm just going to write from the formula, after impact divided by velocity of by B before impact, sorry, velocity of ground before impact minus velocity of B by B before impact. Okay, now we know that before or after collision, the ground doesn't move with speed. Probably does, but it's very, very tiny. So that is 0, and so is this. And so we're left with VYB to divided by the minus sign, VYB1. And so we can write, since we're given E, it's 0.8 equals minus, this velocity here is velocity before impact, right? So VYB after impact is velocity before impact. Okay, so I think I'm to be very, very technically correct, when I take the square root over here, this should be negative, right? Because when you take the square root of this quantity, you can choose the positive root or the negative root, but since the velocity we know is downwards, our convention is downwards is negative, so it should have taken 6.94. So minus 6.94. And so V is 6.94 times 0.8. So I'm just going to write the answer. It comes to be 5.554. So 5.55 with a positive sign, which indicates that it's, when it bounces off, it moves with a velocity which is upwards, which again makes sense. So the last part is projectile from B to C. Okay, from B to C. So again, the same formula holds true. Velocity of Vy B square equals Vy 0 square plus 2gh. Velocity of y when it is in the apex, I'll write here Vyc, right? Because I want to relate the velocity at C with the velocity at B. So I can change the 0 to B. So what's the velocity in the y direction at C? Topmost part. It's 0, right? Because at C, when the ball is at the upmost point, it cannot be going up because it's its topmost point. If the velocity was not 0, it will go up. So it's going to be 0 equals Vyb is known, it's 5.55 square. 2 times gravity is 9.81, the negative sign. H is positive, we don't know what it is, we'll get it when we solve it. So if we solve for H comes out to be 1.57, the positive sign, and that makes sense because it's upwards. Okay, so that's the answer to the problem. It's 1.57 meters upwards.
Can you explain the velocity of the ground again, please?
Say that again.
Can you please explain the velocity of the ground, how it goes to 0, so how you just cancel it?
When you have a ball colliding with the ground, there are two objects involved. We know that the ground does not move when a ball hits because the mass of the ball is like nothing compared to the velocity of the ground or earth, which is massive. Now if it was two planets or two satellites collide, then it's significant.
So that's not trick we should remember.
No, so for the exam, if you have a collision with the ground, I just wrote there for your purpose, for you to understand. That comes from the main equation, but feel free to ignore the ground. If you write it this way, it's right.